Welcome. Thank you for taking the time to join today. And we will start. My name is Oren, and I will present today the architecture of our new software version Annapurna, the first release. This is the second presentation in the series. We did one last week, and we will have another one next week. So what's the agenda for today? So we do a very quick review on the why Annapurna. This was the webinar we did last week. We will take a look into the high level Annapurna implementation. Then we try to just make sure that we all talk the same words, same name or technology, so we review it quickly. And then we describe the pillars, the core pillars of the design. What did we do? Why did we do it? We'll dive really a bit into the architecture, deployment, and migration. And then you will have the time to ask questions. This time, presentation is a bit different with more words and less images, less movement. So I hope it works well. As usual, the webinar procedure. So our team is in the backstage waiting for your questions. So while I present, you can already start asking questions, whatever you want, and they will respond. Definitely in the end, I will take questions and I will respond to them. We might not be able to answer everything. In that case, we will answer offline, and the team will send the questions to everyone on the screen on the webinar. And please remember that we strive based on your feedback and request. Whatever you need, whatever you think, let us know. Before we start, what's the terminology I'm going to use? So the existing version that many of you are still using will be called V25. This is how we do it also in the company. The Annapurna is the current version of our new line of software. So we call everything Annapurna. We don't say new and current and new. This is Annapurna, no new. The next release is going to be a mountain with the letter B. It will take a few months, probably maybe a year. We switch the major to a new release. It's always when we do a major technological jump, then we do it. And we are looking forward for your recommendation also in that space. So now we will review what we did in the previous webinar. But before I start, first I would like to thank our devoted marketing squad that organized this webinar, and we do it all the time, not only me, so it takes a lot of effort to do it. Second, I would like to thank all our team, the OpenLMers, so for their dedication to make this a reality. It's not a small effort, it's more than 3 years that we are working on that. Okay, so why Annapurna? We have many reasons. So we wanted better scalability. We wanted a cloud native deployment. You requested for advanced BI integration and much faster cycles of I requested, you developed, it's working on my system. Or even, okay, there is a problem, you're working and fixing it, I want to get it very fast. So this is an agile world, and we want to be in this there, and we want to be able to provide you a much higher service level than we are able to provide today. So if we take a look on the key concept of the architecture of the new version, so to meet these challenges, we built Annapurna on a foundation of modern, powerful technologies. And before we break down to the core pillar of our implementation, I would like to review each technology that we used, and just to make sure that we are talking the same language, and if I say a name of something, you know what I mean. So let's go through it. I hope it will be interesting. So we are going back to school for a minute, the school on the Himalaya, of course. It's not just a simple school. So first, let's start with microservices. This is built into the core of Annapurna. So we, until now, with V25, it was also, there were multiple parts of the software, but each one of them was a monolith, a very big monolith. And especially the OpenLM legacy server, that was a huge monolith. So with many moving parts, many complexities. And what we want to get is a system where we have many small services, microservices working together. And the term is loosely coupled services. Why? Because each service is doing a very specific part of the work that is typically not related to the other service. It might demand services from other services, but definitely it's a unit by itself. The reason why we want to make them independent is because we can modify a service without breaking the interfaces to the external world, and then we can do it without affecting all the other services. So this is the main concept, I think, in the whole system, loosely coupled services. Now think about that. If in the past we were able to release twice a year sometimes, and sometimes once, depending on the size of the version, every change you do in one place in the software, you need to check everything, because you don't know where it might cause another part of the software not to work, and you need to check it. So in microservices, you know, the change is isolated to a specific software, and we can get to a situation where we can release maybe every day, maybe twice a day. It doesn't matter. Every time there is something to release, even a small fix, we can just go there and do it. And I maybe need to mention that this is not the only mechanism. So one is these loosely coupled services, where there is a separation between the different services. And second, there is a very big verification layer over the system. It is running, checking everything. So when we release, we can know that actually we didn't break anything. So next, let's talk about, so start differently. So we have all these small services. Up to today, it's about 150. So this is a big challenge. So how do you pack 150 services, and how do you deliver them? This is where Docker comes in. Now, if we want to better understand what we're talking about, think about the shipping a container. So all these containers going around the world, and you get your furniture and electronics, and this container, this unified unit, a huge box, can be loaded onto any ship or truck. It's unified inside, and it's fully packed. Everything is inside. Doesn't matter what's inside. You put it on the ship, you take it to the track to get it to the endpoint where it should go. So the guy who invented that is named Malcolm McLean. This was 1956, and he was the owner of a very successful tracking company, but he always grew frustrated with the inefficient and labor-intensive process of loading and uploading and loading and uploading a cargo from ships. If you remember in the movies, you see the porters walking with all the load on their back. And then he changed everything. This was 1956. And now the Docker was invented by Solomon Hykes, and he released it as an open source project in 2013. That wasn't long ago, so it's quite new. And he also founded the company .cloud, which carries on the development of the Docker. He did it with many people. So why is it important? So think about the past. So you want to deploy your software, and you deploy it on the operating system. Now you're dependent on everything that is happening on the operating system. So I still remember on my early stage, this was what we do. We develop something, now we need to deploy it. We come to the machine, there is another system running on it, and IT is saying, no, you break the other system. In the places where I was working, eventually the decision was, let's have a machine per system. And we knew that we are not utilizing the hardware. So one small system on 4 machines, that's what we have. Later came the VM. So say, okay, we virtual the machine, you run multiple machines, you better utilize the resources. But this is still problematic. You're still dependent on the operating system. The revolution of the Docker is that it's packaging everything that you need, this piece of software needs, the infrastructure and everything, into this container. So it's called containerization. And this way you don't have all these difficulties. Each service is running within a Docker. So we are using the Docker as a package. Next, let's talk about Kubernetes. So easily, you type a command that the Docker is running on your Linux machine. It can also run on Windows. Anywhere, you can run Docker. But the challenge is when you need to run 150 services, like we have. So this technology was originally designed by Google. It was an internal project in the beginning, Borg, and then open source project, again, 2014. It wasn't long ago. And it's named after the Greek word helmsman. So this is the person holding the wheel of the ship and taking us to where we need. It becomes an industry standard for everything related to containerization. The Kubernetes is managing and orchestrating everything. So basically there is a full control, and I think I have a slide here that will explain the services of the Docker. So one is the automatic deployment and rollouts and updates. So this is all services provided by the Kubernetes. You can say, okay, look on this repository, and every time there is a new version, download and install it. You can control it. You can do many things, but it gives you a full control over that and management. You can expose containers to the internet or to other containers within the cluster. If traffic to a container is high, Kubernetes can load balance and distribute the network between the different Dockers. So this is the language is pods. So we can run multiple pods of the same service and then be able to address the load, because this is one of the concepts of Annapurna. We can handle any load. Kubernetes is checking the self-healing. So it checks the status of the Docker, and it can reset the container. You get the log, you know exactly what is happening. Another very critical aspect is the storage. So because there are multiple pods, they need to look into the same storage, and there is a whole range of solutions that are related to managing the storage within Kubernetes. It's not easy at all. It's very complex, but once you configure it properly, it works very well. We control the consumption of how much CPU, how much memory each of the container will consume. This is very important because it can get crazy, and without Kubernetes, we can't control that. And everything that is related to the management. So configuration, secret management, SSH key, OAuth tokens. There are many things that you need to take care, and everything is taken care by Kubernetes. So get to know Kubernetes. Kubernetes is typically written not as a full name, but as K8S, Kubernetes. So just to save the letters, and then there is a quiz. So what is the next number in the list? So, and before you get into really thinking about that, let's talk about the API gateways. So the numbers I showed is actually the port numbers that we were using in V25. There were many. You probably know these numbers. But in Annapurna, as we are using microservices, it doesn't make sense. You will have access to a specific microservice. It can, even if you think about that, it cannot work at all because there are multiple instances. So who do you access? So basically, there is a concept called API gateway. And the API gateway is kind of, think about the doorman sitting in front of your office. Someone goes in. We don't have one, but some places there are. So he can verify the identity, make sure that you have access, right? You should be here. Maybe it's a mistake. You shouldn't be here. You can send it to the right room. Okay, good. Go to Steve or go to room 44, whatever. He can gather statistics. The opportunities are endless. So this is giving us security and the ability to control the access to the resources of the OpenLM platform. Next term is Kafka. So if the API gateway is the front door for external communication, Kafka is actually the internal postal service between the services. This is how microservices are talking to each other. When one service has information to share, it sends a message to Kafka. Other services that needs that information can subscribe and get the message almost instantly. The main thing that it's decoupling the services. So instead of using API and sending messages to each other, we put them in a place and then say, yeah, subscribe to it, get it when you need. This is very critical to systems like ours. They are too big. So a very big company created that. LinkedIn, again, 2.11, you see, quite new. It's not an old technology. They wanted to handle the massive flow of activity on their platform. The creator was Jay Krebs, and he named it after his favorite author, Franz Kafka, who maybe you know, he was born and mostly live in Prague, wrote some crazy books. So just two more words. In Kafka, there are topics, and services are publishing into the topic, while other services register to them, subscribe to a topic, and they get the data. Let's take a small example. In order to perform an onboarding actions for a new user, a service might subscribe to a topic that lists all the new registrations. So here's some more capabilities of Kafka. So I won't go through everything. Crazy high throughput, amazingly scalable, almost unlimited. The handling of mistakes, the data is stored in multiple places, so we don't lose anything. It's almost real time. It's amazingly fast, and we spoke about the publish subscriber messages already. So next is Spark. Spark is a technology that is so let's start differently. Annapurna collects a massive amount of data. We are what people like to call big data system, and we need an engine that will process that data and prepare it for reporting. And Spark is able to do it in incredibly fast way, and because it processes the data in the memory. So everything is happening in real time, all the calculation, aggregations, and transformation, and then it's all being transferred into your reporting database, where you can query that using your BI system. Now, let's look into the origin, where it started. So it's in UC Berkeley this time. There is a specific lab, AMP lab, in 2009. And it shows that it could process data 100 times faster than the technology that was before, Hadoop, MapReduce, and it did that in memory. If you remember and you used it in V25, we have used Pentaho, which was a good system, and it's still running, processed huge amount of data for you, but now we are moving to Spark. We're also experimenting with other technologies which are newer, like NiFi, also from Apache, but definitely Spark is the industry standard, and it delivers outstanding capabilities and performance. Next, and I think this is the last one, or maybe one before. Let's talk about, so we have the data, Spark process it, it's now in our reporting database. Now, what are we doing with it? The goal is to use BI tools. And what is a BI tool? So this is systems that allows you to query your database by yourself. So this is how I'm taking it. It simplifies all the access to your data and make it something that not professionals are doing, but anybody. You can do it, anybody can do it. The term was first used in the sense of it's now in a paper from 1958 by Hans Peter from IBM. But it took a lot, more than 30 years to bring it to what we see now. So we see modern tools. I think two of the biggest names in the industry are always Tableau and Microsoft Power BI. And you can do anything you want without the need for IT specialists, someone that knows databases in order to tell you how to do it. You can do it by yourself, and this is the revolution of the BI. So we graduated, we know everything now, and we have the same language. So this was the main purpose. So you probably knew most of the thing, but we now talk the same language, and we can continue the communication in this webinar and also after that in the next in the series. So okay, so how this foundation benefit you directly? So first is and important is updates, a seamless update and targeted update. So we can release a small bug fix in a screen very easily without having any effect on anything else. We can release entire component without affecting other components. This enables innovation. So come up with what you need, and we will try to do it. And this time we have the infrastructure where we can implement that on. It's also more resilience, and it's independent from technology. So you can basically deploy it anywhere you want in any platform, and also have a mix of deployment working together. We'll have at least 2 separate webinars talking about deployments and what can be done. So I will only touch it on a very high level this time. So we go to pillar 2, unified and secure communication. So this is a major pain point from our previous architecture. Many of you know that the headache of managing firewalls, rules for the different ports in V25, you ask the IT, they did it. It takes time, it takes effort. With Annapurna, it's only one. We give you one single unified application gateway, and this is the only way to enter the traffics into the system. It means that there is a very simple set of security firewall rules. It's avoiding mistakes, making it more secure, and as I showed you, it also provides many other benefits. Some of them we're already utilizing now, and some of them will utilize it better in the future. Pillar 3, packaging and deployment. So we are using Docker. So everything we do is packed and shipped to you as a Docker. There is a repository. You can download the Docker's from, and then you can deploy it on your system. It's simplified, it's scalable, and it doesn't matter where you run it. It just works. And this is very critical. It runs on. It's containerized as a Docker. It's orchestrated by Kubernetes, and it means a simplified deployment. Now, many times when I talk with some of our users, not everyone, say, Kubernetes, this is too complex, too new, nobody is using it, it will take 3 years to get it widely spread. And I took 5 minutes before the show to show you something. So look, we are serving many different industries. So one of the industries is GIS, Geographical Information System, and these are some of the systems that are already shipping their server products running under Kubernetes. This is the top technology in this field, all of this one. So this is GIS. What do we have here? PLM systems. PLM is something that is used in any industry, CAD, in EDA, in any other industry, also in GIS. They have their own, they can use this. And these are leading PLM systems. Many of you are using Teamcenters, I know, because we support it. And this is running on Kubernetes. EDA systems, so EDA systems, Synopsys, Cadence, and Siemens EDA. So they are all running on Kubernetes. And it won't stop there. So what we found that many times we come to organizations, our user, sometimes from MP saying, no, we don't have this in the organization. We check a bit more and we see, yes, there is a platform, there is a team that is managing the platform, and it's there. So if you are an organization that has to have on-premises deployment, wants to keep their infrastructure in-house, you won't be able to avoid Kubernetes. Kubernetes is everywhere. So let's move next. And we talk about the fourth pillar is data management. So one of the V25 was a monolith, and it was a monolith also in the database level. So we had one operational database, and everything happened on this database. So we did all the operation, processing the data, storing it. So there is a crazy flow of data into the database. And while we're doing that, all the reporting took place on the same database. So you click a button on the interface, and a huge query is going to the database. And they're trying to address everything together, sometimes causing problems. We had to manage these relational databases and so on. So in Annapurna, we said, okay, we are separating the two databases. Operational database is something that is minimal, designed to serve the microservice. And in that case, we prefer to use a new type of database, new to OpenLM. It's a document database and not a relational database. The second database of the system is the reporting database. It's a relational database, not because we need, but because of performance. It's performing better as a reporting database. And this is something that we invite you to access using your BI tool. The most amazing thing we managed to achieve in Annapurna is that we keep the two databases almost identical in real time. And this is thanks to Spark. So in less than 5 minutes, this was the definition when we designed the system. It's usually much faster, almost real time. You see a record going into the operational database, and you get the same record in the reporting DB. So basically, you can build your dashboard based on the reporting database and get almost a real-time reporting. as we provide all the time by OpenLM, by querying the operational databases. Next is the reporting. So we invested a lot in that, and actually, I must admit, we almost bumped into every possible pitfall on the way. So we tried this and that didn't work, this didn't perform well. It took a lot of time to get to the right solution. So one thing is that we have a star schema. This is a design of a database. It's that is built for querying, built for reporting. So we are talking about facts and dimensions, and this is the way BI systems are consuming the data, and it's completely optimized for speed. So to perform well, and look, I don't want to say unlimited capabilities. Probably there are things you can't do, but I don't think there are many things you cannot do. So it's an open database. The format is open to you. You take your preferred BI tool. Doesn't matter what you're using. Connect to the database and you see everything built in front of you. We also provide huge amounts of dashboards and reports, and we're looking forward for your feedback on that. Interface is something that we invested a lot in. Amazingly, we have a screen from V25, which is interesting, but the interface was completely built, completely redesigned. It's also not a monolith anymore. So the interface was also a monolith. Now it is kind of having different components all running on the same platform. And I think you will feel that you are in a different environment when you use it. Now, what do we target in the interface of Annapurna? Basically, all the configuration, everything you want to configure, you do that, even if it's referring to brokers, agents, whatever is remote, you manage everything in one place from your Annapurna UI. You have the management interfaces. So who is currently using something? Still, we provide that from the operational database. So everything that is operational, you see on the operational interface, and we have some, so these are the reports also that are there. It's limited. It's not what everything that you had in V25. Where are the reports? In the BI system. So we are providing an integrated BI system with the on-premise version, and we have the same for the cloud interfaces. So there is a dedicated BI interface. Can you use your own? Yes, you can use your own. So this is the interface of OpenLM, and so this is very interesting and is growing very quickly. We have all the different components. Components are software that are not running on the Annapurna platform. It's running outside, bringing us information somewhere. Now, this is a very limited list. We have many other things, other development, different release stages, and you're going to see that coming in the future. You can drive a lot more information into the system, and you know what? You can also take information from the system into your preferred platform. The integration is a key concept and a key design factor into the when we did the Annapurna. And this is something very critical in the release. This is going to develop very quickly forward. So now let's see the time. Okay, we still have, let me take last 5 minutes and we'll open it to questions. So now let's see a kind of 10,000 feet view on the system, and let's review it. So here you see different agents that are running in different places. They are coming through the information is coming through the API gateway, like other things, and we are processing it. Of course, we are not doing it in the previous way. Okay, a port connecting by a port. We send the data, it's being stored in Kafka, and there are many workers that are processing the data, and we can process endless amount of information. What do we see? We see a BI access to the system. So here we are using maybe Apache superset in this example. It connects directly to the database using a GraphQL API, and it will fetch the data and bring it to your workstation. We see a demonstration of connectivity of one service, our partners for many years, ServiceNow, and we are integrated with them using Apache Amazon SQS. So it's a simple queue, simple messaging queue, something like that. And we are able to communicate. They support it, we support it, and we are able to communicate with them. And we did some amazing applications already ready on the ServiceNow store. You can check it and you can use it. Then we have all the databases. So we have the SQLDB, which is a relational database. We have a document database. This is operational. This is ours. Redis is a database in the memory we're using in order mainly to make sure that we are synchronized between multiple instances of the same service. This is required. We have Kafka here that you know about, and this is kind of a overall review of the system. So I think this is the reporting SQL in this chart. So accessed here by Apache, and this one is an operational SQL server database, let's say relational database that we are still using. So now the second thing, it's not graphical, it's textual, but let's try to understand one flow is a very simple one, and try to understand how is it implemented on this system. So you have agent or broker, it is sending data through the API, the API gateway, and depending on the source, whether it's agent, it goes to the agent hub. If it's a broker, it goes to the broker hub. Some small processing, and it's being stored into an item. Services that, microservices that were registering to these topics are immediately triggered, and they start processing the data. Now, what we got doesn't have everything. So we get an email, we get a username, we get some kind of a code, workstation. We don't know all the data. So we have an enrichment service, which is going to all the databases, fetching the information you need to be in the database, enriching the record, and putting it back into Kafka again. Here we have the Spark services. So they are triggered by the new Kafka data, and they process it. It's the same, very similar to the Pentaho ETL that you have. Process it and put it in the reporting database. And then you can see this data in your BI dashboard. I hope this gave you some idea about how the system is working. Second thing is security, which is very, very critical to us personally, but more than that, critical to everyone living in this world. So this is top priority for us. And as a company, not even related specifically to Annapurna, we have an ISO 27001 certification. We have a SOC 2 Type 2 document that lists everything we do. And when we are working with you, we can easily show you what's our security standard. We have the best of breed .NET-based identity service embedded into OpenLM, which is implementing industry standard technology like OAuth 2.0, OpenAI Connect. And this ensures for you the security of the system, and so you know that we care about that, and it's very important for us. So I already spoke about that, but we do understand that we are living in a connected system, and if we build something that is saying, okay, no, manage everything with us, don't use any other thing, it won't work for you. So OpenLM is built, Annapurna is built and designed for integration. Use us in any way that is benefiting you, and we will support it. Last, and this is only a word here, because we have 2 webinars following in the next 2 weeks, specifically on deployment. So you can deploy any way you like. So you can deploy on-prem, you can deploy the system on a public cloud. This is our system. Just use our public cloud. You know what is important to understand, that your reporting database is only yours and nobody can access it. So even on the public cloud, we have we made sure that your data is isolated. It's not that there is a kind of public storage and the records are all together separated by subscriber ID or subscription ID. No, it's a unique database that is only yours. And the last option is to deploy a private cloud deployment of OpenLM. We natively, so if you use our cloud, we have a US cloud hosted on US land. We have a European cloud hosted on European land. But you can definitely deploy the system on any platform. As I said, we natively support AWS. This is where we are running, but we are already working with the customer to have a full deployment on Azure as a private cloud, so it will also be supported. So whatever you want to do, discuss with our team, and we will definitely be happy to give an advice. So these are the next meeting. I'm already looking forward to see you and to communicate with you. I will talk about the deployment on the cloud. I always like to dive a bit into the technical details and the architecture. The same a week after, mostly focusing on the on-prem solution and how can you deploy it. And that's all from my side.